Hey friends, in this one, let's take a look at some questions concerning polynomials. Alright, let's get going here. So here's a question. Which of the following are polynomial functions? Look at g of x. It says 13x cubed times 12x to the 7th plus 12. If you work through this like this, then you're going to have the following here, in other words. You multiply the 13 by the 12. You're going to get a number out of that. But what's important is that you have x cubed times x to the 7th. That's going to give you x to the 10th, and 10 is a positive whole number, right? So let's do the multiplications on the side here. I'm going to do the 13 times the 12, so you work through that, whatever that comes out to be here. Okay, so that gives 156. So you're going to end up with 156 x raised to the 3 plus 7 is 10, and then plus 12. This is a polynomial. Polynomial for sure. Notice that is 10, and that's a positive number, and it's a whole number. And then this is just 12. That's a polynomial. It matches the definition. Now look at this one. Where it says 15 and it's over x to the 4th plus 6, it's like 15x raised to the negative 4th and then plus 6. So what does that mean? Not a polynomial. Okay? Because of the negative 4 being present. That makes it not a polynomial. Look at this next one. This is a negative number, in other words. Look at the next one. Now you have the root of 10x plus 4. So what you can do by a basic operation of roots is you can distribute the roots. So you're going to have the following then. 10 under the root, and then the root of x, and then plus 4. And then, if you like, you can write this as the root of 10. And the root of x can be written as x to the 1/2, because that's the meaning of the square root operation plus 4. Again, not a polynomial because of the 1/2. That's not a polynomial. When you have a 10, a positive whole number up there, an exponent, it's a polynomial. Not when it's a fraction like 1/2 or a negative number. Okay, let's look at this next one here. So this is, let's work through it. You're going to have the root of 7, and then you're going to have x times x to the 4th, which is going to be x to the 5th. So notice that the root is applied only to the 7, but it doesn't affect the x part. It's just x to a positive whole number. And then plus the root of 7, and then here it's going to be times 13. And then again times x. Is this a polynomial? Yes, this is a polynomial. The reason is it's x to the 5th. 5 is a positive whole number, and this is like x to the 1st, a positive whole number. So when you have that, it's a polynomial, essentially. That's how you think about it. So these are cases of testing whether a given function is a polynomial or not. Let's move on. Let's look at the end behavior of this polynomial. Negative x to the 4th plus x cubed plus 4x squared minus 4x minus 5. Okay, so end behavior, some key observations or notes, right? End behavior comes from leading term. That determines it. So let's identify it. Here it's negative x raised to the 4th. That's the leading term. The impact of that term is the biggest when x goes to positive or negative infinity. So now, what can you do? Well, take a look. When you have negative x raised to the 4th, it's really like negative 1 times x raised to the 4th, you see? You can separate off a negative 1. Why is that useful? Because it's telling you that whatever happens to x to the 4th doesn't matter, because when you multiply by negative 1, the result will always be negative. You can test, like, let me show you, like test, for example, with x equals a positive 10. So 10 is 10 units to the right of x equals 0. It's pretty far on the right. So you're going to have negative 1, and then you're going to do here, notice the negative 1 is separate, very important to understand, and then 10 to the 4th. So it's going to give you 10 times 10 is 100, times 10 is 1,000, and then times another 10 is 10,000. But then you have this negative 1 multiplying it. So it's going to be negative 10,000 like this, you see? Say test with x equals negative 10. So that now you're going to the far left on the other side. Again, the negative 1 is separate from the negative 10 this way. So test it. You're going to have negative 1. And because you're raising to an even exponent, 4 is an even exponent, you're going to have negative 10 raised to the 4th. Well, what does that mean? That means negative 10 times negative 10 times negative 10 times negative 10. That's going to give you, again, a positive 10,000. But then you multiply by that negative 1 that we've separated off, and you're going to end up again with negative 10,000. So the question is, what is the end behavior of the polynomial? You can answer it now. Left, negative, and then right, also negative. In other words, the graph looks like this. It's going down on the left side, and it's going down on the right side. Okay? It's the same end behavior for both sides because it's this negative here. This negative 1 multiplying the leading term always. Okay, let's move on. The last question, we're going to take a look at analyzing a polynomial. So given this function, p of x equals x times x minus 6 times x plus 2, find its y-intercept. All right, y-intercept occurs when x has the value 0. So you just have to find p of 0. So you're going to have 0 times 0 minus 6, and then 0 plus 2, 0 plus 2. And then you're going to have 0 times negative 6 times positive 2. When you multiply 0 now by the negative 12, you still end up with 0. So the y-intercept is 0. This value here, in other words, is 0, you see? Next part says, find the x-intercepts. Well, x-intercepts are always found as follows. You take the function and you set it equal to 0. P of x equals 0. That's an equation, and you solve the equation. Let's do that. I'm going to do it over here, maybe where I have more room. So in our case, I'm going to set x times x minus 6, because that's the expression that represents it. And then x plus 2, I'm going to set that equal to 0. Luckily, on the left side, we are already in factored form. So what you do is just set each factor to 0 like this. So x is 0. Remember, x right here, that's a factor. It's multiplying it, right? Just like the x minus 6 is a factor. The x plus 2 is a factor. So you set x equal to 0. This here, this is done. Right? There's nothing else you can do with that. So x equals 0, in other words, is an x-intercept. So you'd add that to your list here. You put a 0 in here. Right, then you set each factor equal to 0, so you continue with that. So x minus 6 equals 0. When you solve this, it's going to tell you that x equals positive 6. Right, so that's another value in the list, so you put a 6 in here. And the last one is x plus 2 is equal to 0. So when you solve it, you subtract 2 from both sides. So x will be equal to negative 2. All right, let's come back over here and just put, say, negative 2. So the x-intercepts are negative 2, 0, and 6. Those are the places along the x-axis where the function crosses the x-axis. Let's move on. Here's another question. When x goes to positive infinity and y goes, and there's a question mark, where does y go? That's what we want to answer. Well, let's take a look. Let me just make a copy of this. So remember, it's as follows. P of x is equal to x times x minus 6, and then x plus 2. Let's analyze this carefully. Okay, so we want to look at the end behavior for this function. Well, what you may want to do is, depending on how comfortable you feel with what, obviously, you may want to just multiply everything out and then look at the leading term. That's one way to think about it. The other way is to just drop like the negative 6 and 2 and only look at the leftover part, which would be x cubed. Some people don't feel comfortable with that. They don't fully understand why we would do that. We would do that because when x is a large number, then taking 6 away or adding 2 becomes irrelevant, right? And if you look at this very carefully, it says when x goes towards positive infinity, that's saying x is becoming a very large number. Then y, the arrow says, is going towards something. And the answer is infinity, but why is the answer infinity? That's what we want to know. So to answer this, I'm going to proceed as follows. I'm going to take the x times the x minus 6. I'm going to take x plus 2. I'm just going to multiply it. So I'm going to distribute the x over to the x minus 6. So it's going to give me as follows. X squared minus 6x times x plus 2. So I've just distributed the x to the x to get x squared. X to the negative 6 is negative 6x. And then you do FOIL on that. So it's going to be x squared times x is x cubed. Then you're going to do x squared times 2, so plus 2x squared. Then you're going to do negative 6x times x, which is going to give you negative 6x squared. And then you're going to do negative 6x times 2, which is going to give you negative 12, let's see, x. Now you simplify because the middle terms have the same degree. So x cubed and then minus 4x squared and then minus 12x this way. So now in this form I can tell, take a look. Right, this here x cubed is the leading term. So now let me go back over here and let's do this. So when x, let's say do it this way, okay? When x goes towards positive infinity this way, then what you do is do this. Grab like a big value of x, like 10, and plug it into the leading term. That's how I always do it, and find out what happens. So imagine x is the value 10. Just plug it into the leading term. That determines the behavior overall. So you're going to have 10 cubed, which is then just, well, that's 1,000. 10 times 10 is 100, times another 10 is 1,000. The point is this is going up, right? All right, look at the next one. Right, when x goes towards negative infinity, then you have, well, grab a value like x equals negative 10. So you're going to the left, grab a value, a sample value like negative 10. So you have something concrete to work with. That's going to give you the following now, negative 10, and it's raised to the third. Okay, and now when you go through this, this means negative 10 where should we do it? We should do it below because it's going to take some room. So this is like negative 10 times negative 10 times negative 10, which is then going to give you negative 10 times negative 10 is a positive 100 times negative 10, which is then going to give you negative 1000. In other words, the graph will be going down. So now we know the end behavior. On the right side, the end behavior is up, and on the left side, when x is going towards negative infinity, sample value of negative 10 for that reason, the graph is negative, it's going down, see? In other words, in terms of the graph, we have like a behavior that looks like this, and a behavior that looks like this. So now that we've done all of this, let's do a sketch. We'll grab a coordinate system and make use of the information we have gathered. We know on the left side the graph is going down, so the graph will kind of look like this, okay? We know on the right side the graph is going up, so the graph will kind of look like this. This is the end behavior of the graph according to our calculations. That's good. Okay, now we also know, look very carefully, right, that the x-intercepts are negative, 2, 0, and 6. You want to keep that in mind, okay? Let me put some points on the graph. Negative 2, okay? Let's see, 0, okay, so 0, and then 6 right here. Okay, so 6 is this point right here. Okay, like this, good. Something like that. And maybe move this one closer. I want to keep a decent scale, right? So since this is a space of 6 on the right side, we want to make sure that this is representative of what's happening more or less like this. Okay, so this is x equals negative 2, and this is x equals 0 right here, and this is x equals positive 6 in that position. How do we know how to complete the graph? What can we do? Well, take a look. What I'm going to do is this. Choose a value between negative 2 and 0, like negative 1, okay? And just plug that into the function and see what the output is that you get from that. So like, for example, p of negative 1. Calculate that. That's a bit of a calculation. So let's see. It's negative 1. All right, and that's going to be here, I believe, negative 1 minus 6 it was. And then I think it was negative 1 plus 2. Let me just double check because I've already forgotten. Yeah, this is x minus 6, and x plus 2. Good. So that's why it's negative 1 minus 6, and then negative 1 plus 2. Now you go through this, however you choose to go through it. So it's going to be negative 7, and then this is a 1. Okay, so it's going to be negative 1 times negative 7 is positive 7 times 1 is positive 7. So likely what this means is that the graph is doing something like this, okay? At negative 1, it's kind of up here like this, you see? Now let's choose a sample value between x equals 0 and x equals 6. Some value, like for example 3, because it's nicely placed in the middle between 0 and 6. So we're going to compute then p of, for example, 3. So it's going to be 3, and then 3 minus 6, and then 3 plus 2 this way. And then you go through that process. So you're going to have 3 times 3 minus 6 is negative 3. 3 plus 2 is 5. Then you're going to have... So it's going to get really absurdly large, but it's okay. Or very negative. So you're going to have negative 9 times 5, which is then negative 45. That's a negative number. So the point is, let's see, you have to be really careful. Since that's 7, maybe make this a little bit smaller. I'm not keeping the exact scales, the same scales on the vertical and horizontal. Okay, I'll show you one final graph done by computer shortly, but let's just do it first by hand. But this is like a point at negative 45 right there, see? What is this telling us? Well, what it's telling us is, very roughly speaking, what you can do now is, it's a polynomial. That means it's continuous. That means you can draw it without lifting your writing utensil. In other words, you can draw it going through this x-intercept, like up to here, down to here, and then all the way down to here, and then all the way back to here, okay? And then kind of like shooting off, roughly speaking, in this direction this way. That's the general idea. As you can see, one more time, let me stress this, right? So if you can get the y-intercept, the x-intercepts, the end behavior as I've shown you here, then you mark all of that information in the picture, and then just use a couple other points. Like for example, let me stress, like I used x equals negative 1, so I plugged this value from here into the function just to see what the output was. I also use, let me stress, x equals positive 3 from here, right? Like this location, and I plugged it into the function. I saw the output was down below at negative 45. So this is how you would do this by hand. Now, to finish this up, let's do it by calculator, and we'll compare what I've just done by hand with the calculator output. That's going to be x times x minus 6, and then x plus 2. Let's see whether I've captured the essence of everything correctly, okay? So you see, because some of the values are either very positive or negative, you can't see it all, so just zoom out, there you go. Okay, so let me see, I'm going to have to scrunch this down this way. But the overall idea, as you can see, is correct, right? So let me take this graph and move it into position close to the one I've just done by hand. Hold on, let me move my calculations around. I don't want to lose them, so that's calculation here. The overall picture is roughly the same, and that means that what I've done and information I've relayed to you is the right information. You can always check on a calculator or a computer of some kind. All right, friends, that is it for this one. I hope it's been helpful and insightful to you. Please leave a like, please subscribe. Thank you so much for watching. I will see you in another video. And meanwhile, I'm also going to zoom back out because I want to make sure you can see this at the last stage. I'll see you in another one.